Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us start question number 28 of JEE Advanced 2014 Physics Paper 2 Code 8. So let us solve next question, that is question number 28. Friends, let us solve question number 28, which says that if lambda Cu, that means lambda for copper, Cu stands for copper, is the wavelength of K alpha X-ray line. So K alpha, obtained from when it jumps from second orbit to the first orbit, that is L cell to M cell, K cell. Then this is K, L, M, and so on. So the jump is from L to K, then this is called K alpha. So that means the n value here is 2 and here n value is 1. The transition is from 2 to 1. Anyway, the K alpha line for copper, whose atomic number is 29. So this is Z value for copper. And lambda MO, MO stands for molybdenum, whose atomic number is 42. The wavelength of molybdenum is lambda MO. Then the ratio of lambda copper by lambda MO is close to. Basically, we have to write the expression for lambda in terms of this atomic number. So how to write that lambda in terms of atomic number? So you have to think of Moseley's law. Moseley, he gave the relation between the frequency, root of frequency, square root of frequency over the atomic number Z, and he got something like this type of graph. Now this frequency and this atomic number, square root of the frequency and atomic number. Now we have to find how this frequency and Z are related with a formula, because we know that from hydrogen spectrum we have known that 1 upon lambda is R into 1 over n final square minus 1 over n initial square. This is how is the lambda stands for. This is for hydrogen atom, obviously. And if you want to write for hydrogen like atom, then this 1 upon lambda will become R into Z square, and this becomes 1 upon n final square minus 1 upon n initial square. This is for H like atoms. So, but in this case we have K alpha. So for that, 1 by lambda equals to R into, in place of Z it is Z minus 1 the square, and 1 upon n final square minus 1 upon n initial square. This is for K alpha X-ray. So this is the equation we are going to use for K alpha X-ray, and here it is K alpha X-ray. So for K alpha X-ray we have this relation that we are going to use, and because it is alpha, so this transition is from, as I told you, it is for K alpha, it is from 2 to 1. So this is your 1, that is n final is 1. This should be 1 and this should be 2, because transition is from 2 to 1. So I substitute that, I'll get 1 upon lambda is R, Z minus 1 the square, and 1 upon 1 square minus 1 upon 2 square. If I solve this, this is 4, this is 1, 4 minus 1, 3 by 4. So this is 3r by 4. 3r divided by 4, z minus 1 the whole square. This is 1 upon lambda. Now, why it is z minus 1? That also will let us discuss about that. Why it is z minus 1? Because if I think of any atomic number, suppose I have nucleus here which contains protons, that is z, and there is a first orbit here containing 2 electrons revolving, and the outer one having say 1, 2, 3, 4 or as many as you want. There are 8 electrons in the next orbit and so on. Now the thing is that when the transition is happening from this to this, second to first, this is 2, this is 1, 2 to 1. So there, when the vacancy is created here, this goes out, the vacancy is created and that has to be filled from the second orbit to the first orbit. The transition has to be from this. Then what happens is that when you write the z factor, earlier we are using z factor, z square, something like that. Z is effective z we have to write. This is actually z effective. What is the meaning of that? Because this z is the number of protons present here, but when the transition is from this to this orbit, then if I consider a Gaussian surface like this, then the effective z will be, the z is there, z is plus z number of charge is there, and there is 1 electron is also there. You can see there is 1 electron, because out of 2 only 1 electron is gone, so 1 electron is still present, so this is minus 1, because this electron will cancel 1 proton charge, net charge will be only z minus 1, so this z minus 1 is finally z minus 1, so therefore we are writing z minus 1. So instead of z square, we are writing z effective square, and that is z minus 1 square. It is due to screening effect. This is called screening effect. So therefore they are doing z minus 1 square. No problem with that. R z minus 1 whole square. This solving give you 3 by 4. This is the situation. Now if I want to write the expression for this frequency, under root of frequency and z, this is the relation between z and lambda, but I want a relation between the frequency and this. So if I want to write the relation between the frequency and that, then if I write that, then this relation I am able to multiply c throughout. This is c by lambda, and this is 3rc by 4, and z minus 1 the whole square. Now c by lambda is nothing but frequency, and because c is frequency into lambda, so c by lambda is frequency. Now frequency becomes 3rc by 4 and z minus 1 the whole square. If I take the square root of both sides, then this will be square root of frequency, which is 3rc by 4 root, and this will become z minus 1. So from here we call this as a, so a into z minus 1, and this is the frequency. This is known as Moseley's law. This is the Moseley law. So this actually formula we have to use for this equation. So the Moseley law here is that. So we will use this formula for this k alpha and all. Now you can see the ratio of wavelengths and C is asked. Now I have to write this, that this frequency for second case, or which case it is molybdenum is given in the question. Second case I write molybdenum. First is for your copper given, and second I write for molybdenum. So this is for molybdenum. Root of this must be equal to A into Z1 Z2 minus 1 here, and for molybdenum, or for this 1, it will be Z1 minus 1. So these two situations, I'll divide these two equation, and I'll get mu2 over mu1 under root equals to A Z2 minus 1 divided by A Z1 minus 1. A cancels out, and if I take the squares of both sides, this will be mu2 over mu1, that is equal to Z2 minus 1 divided by Z1 minus 1 the whole square. Now if I put the value of Z2, because Z2 stands for molybdenum, this is for Z molybdenum, which is that is given in the question, and that is coming out to 42. That is 42. This is Z molybdenum, and this is your Z copper. So it is 42. So I'll write here, this is 42, and Z1, this is for Z copper, which is 29. Putting that, 42 minus 1 divided by 29 minus 1 the whole square. This becomes 41 divided by 28 the whole square. This is frequency. So frequency is I can write that velocity is frequency to wavelength. So frequency is inversely proportional to wavelength. So this frequency mu2 over mu1 can be thought of as lambda 1 over lambda 2, because the inverse ratio of this is this is equal to the wavelength ratio. That means the frequency ratio 2:1 is same as wavelength ratio lambda 1:lambda 2. So that is nothing but lambda 1:lambda 2. But lambda 1 stands for copper. So this is lambda copper for lambda molybdenum. This is lambda copper for lambda molybdenum. So finally we got to the point that lambda copper by lambda molybdenum is close to. So we got lambda copper by lambda molybdenum is this. So you have to solve this value and get the answer. If I solve this, I have to use that calculator, but in your exam you can take this 30 and take this as approximately what I should get. Approximately, if I use that, then what I will get. If I see the options, it is 1.99 and 2. These are very closely numbers. Then I have to see, and also 0.5 and 0.48. These are very close numbers. But let us try with the. Then we'll apply the logic. If I consider this as 30 and this as 40, then this will be approximately 40 by 30 square. So this is 4 by 3 square, which is 16 upon 9. So it is 9 1 9, and it is 70. Then it is 7. 1.7 something I'm getting. This is my approximate answer, that I'm getting 1.7. But because this is more and a little more, but this is more, this is less actually, so this number might increase. So if this number will increase, then it will increase to what number? If I take 9 and this is 16, or if more than that, it is more than 1.7. If it is more than 1.7, then we have got two options also, 1.9 also 2.1. Then we have to go for exact calculation. If I go for 41 square and 28 square, this, if I keep the same 41 if I keep this 41, because I have to use calculator only, because the answer is there, 41 square divided by 28 square, this is the answer. Then I will write this, I will just put this value 28 square and 41 square, and we'll get the answer, and that answer comes out to be 2.14. That answer comes out to be 2.14. You put that value exactly, you're getting 2.14. I can little solve for you, because the answer is closely, two options are close. I will just tell you how to do that. You can take this as a 40 or 42, one only you change, then you simplify that. If I take 40, then my answer will literally increase by that. I'll take 40 here, 40 by 28, simplify. This becomes 20, and this becomes 14. This becomes 10, this becomes 7. Then that is fine. 10 by 7. 10 by 7 is your 100 divided by 49. This is 100 divided by 49. This is 28, this is 14, this is 7, this is 40, this is 20, this is 10, 7, 49. So it is, if I say it is nearly equal to 2, because it is greater than 2, even greater than 2, because if I take this is 50, then this is 2. So it's little greater than 2. So answer has to be little greater than 2, and if I should see that, then this is the possible answer. So this is the correct answer. Even if you don't solve it, you can still get which one is the correct answer. The answer has to be little more than this. So little more than this, and I'm getting still here it is more than 2. So answer will be 2.14. So that is the answer to this question. Okay, thank you.